Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 10th, 2025, about 3 days ago. This paper introduces a new framework that allows any designer to create a full 4D character animation using just a single reference image and a simple 2D pose sequence. The paper is titled CharacterShot Controllable and Consistent 4D Character Animation, and as we'll see, the results are really impressive. To make this possible, the authors also built a huge new dataset called Character 4D and a corresponding benchmark to evaluate this kind of animation. Also, the authors shared their project on GitHub, and it's the official spot to watch for the implementation. Right now, the full code is still on their to-do list. But you will find the paper there, and you can track their progress as they work to release the code. Over on Hugging Face, you can find the CharacterShot and Character 2D models, complete with downloadable weights and usage examples to get you started. So this first figure gives us a great overview of the entire CharacterShot pipeline. On the far left, you see the simple inputs, just a single character image and a 2D pose sequence. The system then generates these multi-view videos, showing the character from different camera angles performing the motion. And finally, after an optimization step, you get the final 4D character animation. This is essentially a 3D model that's animated over time, which is where that fourth dimension, time, comes into play. Let's trace the data flow in more detail. On the left, the system takes the single reference image and the 2D pose sequence as inputs. The core of this stage is the new dual attention module, which is part of a larger DIT block. This special module is responsible for keeping the character's appearance consistent across both time and the different camera views. It processes all this information repeatedly to generate the final multi-view videos you see on the right, which are both smooth and consistent. Moving to the results, this table shows a quantitative comparison for that multi-view video synthesis stage. The methods are evaluated on several metrics. For example, SSIM measures image quality, where higher is better, and LPIPS measures perceptual similarity, where lower is better. As you can see, CharacterShot, on the bottom row, consistently outperforms other models like SV3D and SV4D by a large margin across all metrics. This indicates superior image quality and much better preservation of the original character's identity. This table then details an ablation study, which shows how each piece of the model contributes to the final performance. Starting with the baseline, you can see that adding the camera prior gives a nice boost to the scores. But the real magic happens when they add their proposed dual attention module. That third row, representing the full model, achieves the best results across all metrics, especially in perceptual quality and video consistency. This clearly demonstrates that the dual attention component is critical for generating these high-quality animations. Building on that, this table compares the final 4D generation performance against other leading methods, like Stag4D and L4GM. Across all the metrics we've discussed, like SSIM for quality and LPIPS for perceptual similarity, the results are decisive. The bottom row shows that CharacterShot significantly outperforms all the others. For instance, its scores for the various FVD metrics, which evaluate video consistency, are often less than half of what the competing methods achieve, showing a huge improvement in stability. And those impressive numbers really come to life in this visual comparison of the final 4D generation. Each row here shows a different character, starting with the input pose and the ground truth for reference. Then you see the output from CharacterShot, followed by several competing models. If you look closely, especially at the results from methods like SC4D or L4GM, you'll notice artifacts, like blurry textures and some distorted details. In contrast, the CharacterShot generations are consistently sharper and much more faithful to the original. So, to wrap up, CharacterShot truly stands out by making high-quality 4D animation accessible from just a single image and a simple pose sequence. Its dual attention module is clearly the key innovation, ensuring the impressive visual consistency we saw across all the results. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.